Yeah,
I should. I've like actually talking about that. I'm like,
so at least like not. Just
Hi, good morning, everyone. Nice to see you here. Take a minute here and we'll get started. Few people taking their coats off. If you're joining online, thanks for joining online. All right, let's get started. I've got a few announcements to make and we've got some review to do, and then we'll talk about memory and thinking. So first, if you're interested, this was sent around to, I think, all instructors in psychology a few weeks ago. If you're interested in joining the Western Psychological Association, that's one of the clubs that's on campus that focuses specifically on psychology-related issues. I'll put this in the slides. It's not on the slides that you have because I forgot to add it until this morning. So I'll add it on the slides that you have on your site. I'll also put an announcement, or you can just scan it right here. This is really just general information. So if you're interested in joining, there'll be more information available with the QR code. There's things like occasionally they have, I think, dinner with a prof, which I've done a few times, which is a lot of fun. But there's lots of other profs you could have dinner with too. If you think that kind of thing is fun, that's one of the options they have. Networking nights and all of those types of things. So if you're interested in psychology and also want to have an additional club that you participate in, this is a particularly good one. So that's announcement number one. Announcement number two is we've got quiz one available today. So first quiz of the year. It'll turn on if it isn't already. I think I set it so that it will be active at 12:30 p.m. today, and it's multiple choice. One small change, when I was setting it up, I set it up to actually expire at 12:30 a.m. Tomorrow. So it's actually going to be open for 12 hours instead of 10. Doesn't make any difference. It's still a lot of time. It's multiple choice, open format, 15 randomly chosen questions. So not everybody has exactly the same questions. The questions and answers will be available after it closes for everyone. So it closes again at after midnight tonight. So at 12:30 in the morning. You can take as long as you want to finish it. It's not timed. It's not a difficult quiz. It's possible that you'll get all of them right. Maybe you'll get only 12 or 13 of them right. That's fine. It doesn't count a lot towards your final grade. And it also doesn't cost you a lot if you don't score very high. These are really just ways to help you prepare for what's going to be on the midterm, which is coming up in just a few weeks. So the questions are going to be drawn from units 1 through 3. So that's first class, second class, and today's class. Stuff we talk about today might appear on the quiz, which is why it usually doesn't open up until after the end of today's class. So we'll get through everything today, then you can take the quiz whenever. Remember that if you do have a, if you forget to do it, there is no makeup for it. So it will just be dropped. There are only 4 quizzes that I'm going to count, but I'm going to give you 5 opportunities to take a quiz. So if you miss one of them, no big deal. It'll just be the lowest one that gets dropped, and I'll still just only score the 4 highest marks. Any questions on our quiz today? Okay, then let's get started. I think those are the only 2 announcements I have. Let's review. So I looked at the foggiest concept, and not surprisingly, triangle inequality was the one that came up the most. Somebody said, I can't tell if I'm just gaslighting myself into believing that I understand it. That's possible. Perhaps you've gaslighted yourself into thinking you've understood it. Let's talk a little bit more about triangle inequality. It's not the biggest concept that I'm going to test on, but there are often questions on final exam, or sorry, on the midterm exam, about similarity. And I think I already hinted that I usually ask a question in some fashion about some of those assumptions of this geometric model and ways in which people's behavior either aligns with it or fails to align with it. And this violation of triangle inequality is one of the ways in which people's behavior doesn't always align with a geometric approach. So let me go through it in a little bit more detail in a slightly different way. So this is what how we described triangle inequality. And just backing up, remember, this is one particular model of four that we talked about ways in which you as a human might represent things in your mind and how you might make similarities calculations, how you might make decisions about whether things are similar or not. The geometric model was the first one we talked about, and it relies on the assumption that psychological space is analogous to physical space. Things that are close in physical space are close in psychological space, meaning they are highly similar. So distance or dissimilarity, amount away from something between 2 points, A and B. So two concepts, two ideas, two perceptions, two things, cannot be more than the distance between A and a third point, plus the distance between C and B. That sounds kind of confusing the way I've written it, so I put it in a simpler equation. The distance between A and B has to be less than A and C and B. And that suggests that if all of the things that you know about, all of the concepts or all of the objects that you've rated in similarity can be plotted in 2 or 3 dimensional space, that any 2 objects are going to be closer than any 3 objects. That's really what it means. A straight line connecting 2 points is going to be the shortest path. Let's look at this in a number of different ways. And I think I've sort of reconfigured how I wanted to explain this, and I hope that it'll seem clearer after this. Okay, so first off, one question that has come up in the past, and one question that came up individually was, does everything a right triangle? So I gave an example of sort of a right triangle in that grid of shapes. But the idea of triangle inequality would hold regardless. So A and B, this line here, has to be less than these 2 lines, right? A and C and B. It's going to be true whether it's this kind of right triangle, whether it's going to be this kind of triangle, or whether it's going to be this kind of triangle. That AB line is still going to be less than the sum of the other 2. Does that make sense to everyone? So however we've decided to configure objects in psychological or physical space, this triangle inequality, this idea of triangle inequality should hold true for physical space. Then we suggested that perhaps maybe we could consider a set of objects, circles in this case, that vary in size and color, and that what you would do in order to determine how these sit in a psychological space is first you would ask your participants in an experiment to just rate the pairwise similarity of all the possible stimuli. This idea that objects are sitting in this 2 or 3 or multidimensional space is one that we can derive from people's similarity ratings. So it isn't the case that they're guaranteed to be in this configuration. This configuration is one that we might derive based on people's ratings. So we're going to just ask our subjects to look at all of these objects and rate the similarity along all of the pairs. And so you might see these pairs and you would give them a very high rating. This would be a rating of 7 on a scale of 1 to 7 because these things are identical. These are the most alike that they could be in the set. These might be pretty close. Even though they're different in color, they're the same size, right? So you might give this a high number too. You might say this is a 6 out of a scale of 1 to 7. Does that make sense to everybody? And so we're going through asking our participants to rate all of these things. Here are some things that are different sizes, but they're the same color again. Here are some things that are both different size and different color. And this is one of the ones that maybe is a little bit critical. They're not that far away from each other. They're still circles, they're still colors, but they're different size and a different color. So what we might see is that participants would give this a lower rating than perhaps maybe a pair that match on a particular feature. In other words, this pair here, which matches on color but not on size, might be given a higher rating of similarity than this pair here, which is a mismatch on size and color. Does that make sense to everybody? even though there might only be 1 unit apart in terms of all of the features that we're counting on. And so we keep on going. We ask everybody all the possible pairs, keep on going. And then what we can derive is a multidimensional scaling solution. Now, if everything is equidistant, if similarity is something that is counted up by shared features, we might arrive at something that kind of looks like this, where everything that's 1 unit apart in terms of similarity would be highly similar, and it would be close in this multidimensional space. Things that are more than 1 unit apart would be further away in multidimensional space. And our geometric model would then predict that the similarity that's rated between A and B and A and C, this AC combination here, should be less than the similarity that's rated between A and D and C. Does everybody get that so far? So again, this grid is one that we would derive from ratings. But it turns out that if we derive your ratings on these kinds of objects, it doesn't always come out this way. What happens is that instead of psychological distance tracking physical distance in this multidimensional space, what we have is something like a triangle inequality. In other words, depending on the pairs that are being asked about, the pairs that I'm asking you to rate, the shape of the triangle shifts. If I'm asking about things that are high in unidimensional similarity, this is what my multidimensional scaling solution should look like. A and D would be really close to each other. They would show up closer on this multidimensional space because they are a perfect match on one dimension, even though they mismatch on another dimension. Then, if I ask you to make some other rating, so I've got these high similarity and low similarity pairs, this is a little bit lower than this match. So this is what our shape looks like. But suppose then I ask people to make ratings about D and C. Again, they're different size now, but they're the same color. They might get a higher rating. They're more similar than they should be. And so D shifts in space when it's being compared to C. Again, because of a unidimensional match. This is the idea of triangle inequality. Depending on what you're comparing, the shape of the multidimensional space seems to shift. It's contextual. And that's true of some of the other violations. When we talked about the symmetry violation of multidimensional space. The symmetry violation is also one that depends on context, depending on which thing you ask about first. If you make the comparison between A and B and C, or A and B versus B and A, sometimes the similarity shifts. And so all of these assumptions seem to suggest that our ratings of similarity are not purely perceptual. Sometimes they're based on context, they're based on what we know about objects, and sometimes they're just based on the way in which objects are compared. And so it's not a static thing, it kind of shifts. And so triangle inequality suggests that depending on which pairs we're comparing, this D item in this particular example can shift around a little bit. The psychological space or the axes can compress or stretch depending on the nature of the comparison. So what this means is that psychological space is not purely analogous to physical space. It shifts in a way that physical space doesn't. Does that seem a little clearer? If you can continue to gaslight yourself into thinking you understand it for a little while longer, that's fantastic. I don't think you're gaslighting yourself. If you think you understand it now, I think you probably do understand it now. Are there any other questions about this before I go on to the other topics today? Yeah.
Remember you talking about how it was basically like A and C will be closer than like A and D plus D and C. Is that part of the triangle influence? Because
Yeah.
like it doesn't seem like that'll still be true when it's shifting.
So it wouldn't still be true in this case.
Okay.
And I'm sort of showing how it would build up based on pairwise comparisons in this example. The idea is that this triangular shape changes depending on what the comparisons are. This ABC line, which should be shorter, ends up being longer because we often have more space to transverse. Does that make sense? So that's one of the root ideas here, is that these concepts of similarity shift and change depending on how things are asked of them. That's true for a lot of psychology. How you ask the question can affect the answer itself. Even in something like perceptual similarity for objects as simple as shapes of different colors and different sizes, which should be really straightforward. There's only 2 dimensions and they only vary in a few ways. We should be able to get pretty standard ratings, and yet it still doesn't seem to be the case. How you ask the question can affect the type of answer that you get. Okay, let's talk now for the rest of the day about memory and thinking. Now, those of you that have taken, I know some of you have taken 2135 with me as an instructor, and some of you have probably taken 2135 with Dr. McCrae as an instructor. We use the same textbook and a lot of the same slides, so it's a lot of the same content. If you've not taken 2135, this will sort of give you, that's the course in cognitive psychology. This will make sure that you've covered some of those concepts. So you'll probably recognize some of these slides and some of these ideas from 2135. In fact, this very slide might have been one that I used in the introduction to the memory lecture that I gave 2 years ago if you were in my class. So if some of this seems like review, that's okay. It's okay to review some concepts and see how they work. But what we'll do is we'll talk about this more from the perspective of how memory influences your thinking process, decision making and judgments, assessments about people, assessments about situations. But at the same time, I will go back and talk about working memory, and we'll talk about different memory systems. So some of this will be a little bit of review of material you covered this year or last year or 2 years ago in 2135. Some of this, of course, will probably be review of stuff you talked about in intro during the lectures on memory. That's how psychology works. You kind of build an understanding. So what do we use the past for is the question that we're going to cover today. Any kind of intelligent system, whether it's you or me, your dog or your cat, or even your artificial intelligence system that you use. When you rely on ChatGPT or Copilot or Claude or any of the other really good large language models to do some of your thinking for you, it's helpful to have it remember what you asked it yesterday, right? And so you probably continue specific chats in order to make sure that it remembers if you're working on a problem, if you're working on a paper, or if you're working on a trying to come up with a solution to something. If you're doing some coding work and you're using an artificial intelligence system, you don't want to keep asking it the same thing over and over again. So you might stick within a particular chat or even develop an agent that works on something specifically so that it has a memory too. Memory helps you do your work better. It also helps artificial intelligence do its work better. And so whether or not this memory is digital in nature or electrochemical in nature, which would be the case in your cortex, the idea is that you're re-experiencing things and helping you to solve problems more efficiently. We can define memory as recognizing a pattern of activation that's occurring now, so neural activation, as being similar to a pattern of activation that occurred before. So again, there's a reliance on similarity. Memory relies on similarity. Something that happens now that might be similar to something that happened before, you would experience that as a memory. You would say, this is familiar. I recognize this situation. Or somebody might ask you a question and you would recall that information and you would again be using some metric of similarity to be able to take the memory probe, whatever you were asked, question, and to be able to compare that to something so that there's a degree of similarity. You recall your memory, you're recalling something that's similar. You can rely on memory. This is similar to what we keep using the word similarity. This is kind of similar to what we talked about last week when we said you use similarity to do all of these things. Well, you also use memory to plan interactions, to learn new skills, to select behavior, and to use memory to solve problems. Sometimes it works, sometimes it doesn't. So let's talk in the first half of this class about ways in which your memory affects your thinking ability. And then we're going to talk about a couple of different ways to approach short-term memory, long-term memory, and then we'll talk a little bit about memory errors. So this particular slide, I think I've used this in my lectures for a while. This isn't anybody in particular. I certainly wouldn't allow my own children when they were this young to sort of behave this way in front of the stove while I'm just taking a picture of them. That seems a little unsafe. The stove is clearly on. You can see the blue from the gas right there. So instead of stopping the child, the person just took a picture of them, which seems a little unsafe. So the reason I use this example is that most of us, when we're little kids, we're probably told not to go too close to something that's dangerous, right? You don't remember that, of course, because you don't have any memories from when you were this young. But certainly you can imagine, how many of you have a younger sibling that you've probably tried to help in particular ways? How many of you have watched another child, whether it's babysitting or childcare or anything like that, or a school setting? You got to stop little kids from making mistakes sometimes, not walking out into the road, not putting their hand near the stove. And of course, if you're a little toddler, you have no idea that this is dangerous. I mean, from your perspective as a toddler, you rely on your memory to make decisions. If I'm this kid, and I haven't burned myself on the stove, I don't really think of the stove as being a dangerous thing. I probably just think of the stove as being a place where one of my parents spends a lot of time right before I eat. And so that's kind of a good association. So the memory that's there, the memory that's most available is to be able to want to be near it. That seems like the kind of thing I'd want to be near. This is what I'm going to be eating in a few minutes, or my parents are going to give me little bits of it. So there's a lot of good associations there. That association is a positive one. You don't want your child to accidentally pull down the handle from that pan and spill the food on themselves. So what you'd normally do, what would you normally do in this case if you were walking in to your kitchen and the toddler was right there reaching up to the stove? What would you say? What would be your first reaction as a caregiver? You'd say, yeah.
Stop.
Stop. You'd say stop, and you probably say it in a slightly frightening way, right? You wouldn't just say, you might not want to put your hand there, young child. You'd probably, I don't mean you wouldn't yell in a cruel way, but you might try to startle them in a way that suggests this is not a good place to be, right? So you might yell stop or speak loudly or in a slightly frightening way, mostly to create a new memory for the child. So what the memory that the child is going to have is that when I get close, something a little uncomfortable happens. Just a little uncomfortable because my mom or my dad or my caregiver kind of yelled at me a little bit and frightened me a bit. So you want them to have a little bit of that slightly frightening memory so that the next time they get close to it, they worry, oh, I hope that doesn't happen again. Maybe I'll just back away from the stove. So you're replacing what could be an otherwise really painful experience, which would also make them not go near the stove, with the one that's slightly less painful. Either way, you want them to have this association. You want them to rely on their memory to say, don't go near the stove. And that way the child is using that memory to assess behaviors. If it happens tomorrow, the first thing that should come to their mind is, oh, yesterday I got in trouble. I mean, they don't say it that way themselves because they don't have language yet, but they kind of think that. Something happened bad the last time. I better not get too close this time. So what we're going to talk about in the next few slides is something called availability heuristic. You're probably familiar with this. If you haven't learned about it in my cognitive psychology class, you've probably learned about it in other classes. Can anybody give me a good description or an example? We'll talk about some, but what's an example of an availability bias, an availability heuristic error?
See a lot of statistics about car crashes. You think you're more likely to get into one.
You might see a lot of statistics about an accident, like a car crash. And so maybe you overestimate your risks of getting into one. That's a great example. And you've probably even read about things like this. How many of you are planning to go somewhere over February break that's going to require you to go in an airplane? Okay, so maybe you're going to go somewhere. Do you ever think about the airplane having an accident? Probably not, but maybe every so often it crosses your mind. And you've probably had people say to you in a kind of an irritating, mansplainy kind of a way, you know, you got a better chance of being in an accident when you drive to the airport than actually being in a plane crash. It's technically true, but it's kind of not helpful if somebody says that to you. If you're a little worried about something, But that's true, right? So we might overestimate things like that happening because they're easy to think of. They're available in your memory. So an availability heuristic means that you base behaviors, judgments, and decisions, and so on the memories that are most available in your mind, the things that come to mind most easily. Things that come to mind easily are things that happened recently, or memories that are strong or that have a strong association. That's why we want the child here to have a strong association with staying away from the stove. And that's why we might yell at them when they get too close. And again, not yelling in a nasty way, but just enough to sort of give them a little bit of worry that this is not the right thing to do. We want that to be the first thing that comes to mind so that when they get closer, they remember, oh yeah, I shouldn't be near this stove. So availability means basing behaviors on the thing that's most available. And of course, it's usually good. Mostly what's available to you is things that have happened to you recently or things that happen a lot. That's why they come up in your mind easily. And so it tends to be a really good way to make decisions. It can be a bias because it might not be correct. If the wrong information comes up, then you're not going to make the right decision. So I talk about this a little bit in the textbook, but not much because my textbook was written prior to the COVID pandemic. How many of you remember what life was like during that early part of COVID? How many of you have completely wiped it from your memory as much as possible? I've tried also to wipe it from my memory as much as possible. But you still sort of have some memory about what things were probably like during that time. And what things were probably like for a lot of us, certainly this was true for me because I'd been a professor for 18 years or so by the time Western went into sort of its lockdown phase. How many of you were students here when Western was mostly online and closed? That sort of preceded most of you. But in 2020 and 2021, Western was completely shut down. In fact, the first year, I think fall of 2020 was extremely weird because first year students were on campus only. So first year students were allowed to still live in residence, but they took all their classes online. So it was kind of a bizarre setup here where we had only first years roaming around campus and everybody else worked from home. I wasn't in my office for over a year. I just assumed that when I got back to my office and opened it up that there would be spider webs everywhere. I was like, that's what I was most worried about, coming into my office after 9 months, opening it up and seeing like, has something grown in here? It didn't happen. But it was a really weird time because most everything was being done online. And I had written about this. I'm not going to link through these, but these are both articles. One was one that I wrote about in the fall of 2020, and the other one's from a different article, essentially just suggesting that a lot of people had memory errors, myself included. And I had thought about cognitive psychology and explanations for it. And the reason why it seems to be the case is that, and this is true for me, but this is true for most people, a lot of memory, a lot of things that you do in different places. As a student, you have your class here. So psychology of thinking is here in Arts and Humanities 1R40. And you have different classes in other buildings. And you study in the library, maybe, or back in your apartment. If you're part of a small lab group, you do the lab group in the laboratory room. If you're doing research, you might do research with a professor in their lab. And I found that I was doing everything online, that everything just started to look the same. I might be talking with one student for 10 minutes about the wrong project. Still sometimes do that, but not as bad as I did in 2020. Or I might confuse one meeting for another. A lot of these mistakes were what were called source memory errors. They talk about in the textbook. A source memory error means that you remember something. It's familiar to you, but you remember the wrong source. So you know that you did something, but you connect it with the wrong source. I remembered the student, a topic, and a meeting, but confused which one was which. I was more like the stereotype of the absent-minded professor than I used to be. And then I realized a possible source for the problem. Everything looked the same. I was looking at the same screen on the same computer in the same room for everything. Not typical. For my entire career as an academic, I've always been in different places for different activities. Lecture in a classroom, seminars in small rooms, meet with students in my office, meet with colleagues at a cafe or on campus, committee meetings in meeting rooms and boardrooms, data analysis in my office, right at home, sometimes maybe at a local cafe, different places for different tasks, and you kind of get to associate those places with those tasks. But now everything was in one place. Teaching, research, writing, advising, all online, all looked the same, all on the same screen on Zoom in my home office. I no longer had the variety of space, time, location, and context to create those different cues. And that's really important for memory, is that you want to have the actual content of the memory, the facts that you're trying to remember, but also all of the other context. If everything starts to look the same, then you really can't rely on those natural kinds of contexts. How many of you sometimes find yourself in that situation where everything sort of seems the same? You might be doing a lot of your things in the same place. If you're doing a lot of work online, and this was true for university students and professors back in that early part of COVID, was probably true for secondary school students if they did a lot of stuff online. Everything was just kind of the same. It's just in my room on the same screen. And not only is it the same screen that I'm taking all of my classes on, it's the same screen that I'm doing all of my non-academic work, whether that was wasting time on Twitter, watching movies, watching Netflix series. It's just all on the same screen. Nothing really looks different. We need a lot of rich cues to be able to have a useful memory. Other things, of course, that came up during this era, when you're sick, legitimately sick with a virus, not just COVID, this is true for the flu, it's harder to think, right? You do get some degree of brain fog. You do get some degree of fatigue. And some of this comes from general inflammation. Some of it comes from general tiredness. It's not yet it's poorly understood. It's not yet fully understood how these kinds of neuroinflammations might lead to memory errors. But a lot of them have to do with this general cognitive fatigue or this general slowing process. All right, so that's one example. If everything starts to look the same, it's really hard to make distinctions. Another example, and this one I talk about in the textbook, and I appreciate that the example is from 2014. Probably most of you weren't Baltimore Ravens fans back in 2014. But it's a particularly good example because it shows how public behavior, and we'll come back to public behavior a little bit later in the second half of the class. It shows how public opinion and public behavior can be shaped by one or two instances. So I like this instance because it happened in real time, in the sense that people were surveyed, and this was also a time when video evidence of things was still relatively new. 2014, people didn't have ready access to TikTok because there was no TikTok. Most people didn't carry around smartphones with good video cameras. So it's kind of hard to have video evidence of things. That's really different now. Most of us have video evidence of all sorts of things, even though we don't always believe what we see. But in 2014, there were several NFL players who were accused, arrested, or implicated in high-profile cases of domestic violence. Ray Rice was one of them, star running back on Baltimore Ravens, and there was a lot of media coverage because there was a video of an incident of him assaulting his girlfriend. It's kind of hard to downplay the effect of seeing that, right? So if you see someone who is assaulting their partner, it's clearly domestic violence, right? And that's exactly what it looked like. And that's what it was. Shortly afterwards, there were a lot of Americans were upset about this, rightly so, because you should be upset about domestic violence. Nearly 70% of Americans endorsed the opinion that the NFL had a troubling epidemic of domestic violence. So it's one thing to say, I don't accept that there should be domestic violence. It's another to say the NFL as an organization has an epidemic of domestic violence. The reason I like this example is that people are basing their opinion on one case that happened to be high profile. Had there not been video, it might have been the case that Ray Rice was charged. Maybe he went to trial, but people wouldn't have seen the video. And without seeing the video, it doesn't seem as high profile. It doesn't appear, so in this particular, this is from an essay, an article at the same time called Real Clear Science. So why then does 69% of Americans believe that the NFL suffers from this widespread epidemic? The answer is rooted in how we think. Humans are prone to rely on examples that can be easily recalled. The idea is that if we remember it, it must be important. This mental shortcut is termed the availability heuristic. A key drawback of the heuristic is that it leads us to overestimate the prevalence of memorable events. So if there's one event, one NFL player who you've seen the video over and over again, it's going to overestimate how likely that is, because most of us don't know what goes on in the personal lives of every NFL player that year. You just can't. I mean, that's not something that not something we have access to. And so in this article, in this essay, suggests that most people are unaware of the base rates of things. How many of you would have access to information about, set aside NFL players, just in general? What's the incidence of people being arrested for domestic violence? What's the incidence of people being arrested for DUIs or disorderly conduct, gun-related nonviolent sex offenses, theft, domestic violence, nonviolent? Lots of different kinds of arrests. Most of us have no idea what the base rate is in the population of people in the United States who are of the same age, men 25 to 29, which is kind of the average age of NFL players. I have no idea whether or not American men between 25 and 29 are getting arrested a lot for these things, or doing these. It's not something I have ready access to. So I don't know the base rate, nor do I know the rate of domestic violence or DUIs or anything like that for NFL players. And what they determined was when you look at the overall averages for the NFL, in almost every case, the incidents are lower. NFL players on average are less likely to be arrested for a DUI, assaults, drug-related offense. It doesn't mean that it doesn't happen. It just means that it's a lot less likely. And intuitively, that should probably make sense. There's a lot of pressure on doing things, not making mistakes like that if you're an NFL player. You have a lot of supports if you're an NFL player. If you're a professional football player, you have professional chef. You have supports around you. You have staff members. You have people to manage your schedule. So you have a lot of things at your disposal to make sure that you're not going to make these kind of mistakes. Doesn't mean it doesn't happen. It's just not very likely. Whereas the national average for men is much higher. So things like domestic violence are problematic for anyone, but they're not especially problematic for NFL players. And so this suggests that we take one example or two examples that happen to be high profile that we might think about and have seen a lot of coverage on, which would cause us to overestimate the likelihood of it happening. Does that make sense to everyone? Yeah.
In this situation, is it more of a availability heuristic or like a group attribution error?
Sorry, I didn't hear the second half.
A group attribution error.
Both of these things could be likely. So in this case, it probably is more like an availability heuristic rather than just attributing things to a group. So the question was, is this more about availability or more about attribution errors for groups? And I think those things would play into each other. They would influence each other. So the other half of this heuristic that we're going to talk about later is something called a representativeness heuristic, which is closer to this group attribution. Once you've decided on availability that NFL players are more likely to be committing acts of domestic violence because you remember one case, you might then attribute everybody in that group to say, well, if Ray Rice did it, probably all NFL players are engaged in domestic violence. And so you start to think, if you have one example, that example is representative of the entire group, and the whole group has those characteristics. Again, that's a helpful heuristic often, but it can also lead you to make a bias. We won't talk too much about representativeness today. We'll talk about representativeness next week and the week after when we talk about reasoning and concepts. Is that good so far? Let's do some more examples. So here's a good definition. So we've been talking about availability in different ways. Here's a definition I like: thinking or executing a behavior based on the first similar example that comes to mind is known as availability heuristic. Great definition for it. Things come to mind for lots of reasons, but usually because they're salient, recent, or occur often. So frequency, salience, and recency can all be reasons why something comes to mind, and they're all ways that your memory is going to be influenced. This work goes back to Kahneman and Tversky's research in the 1970s. We've already talked about some of Tversky's work, and we're going to talk a lot more about their work in this class because it's two of the foundational researchers or foundational theorists in the psychology of thinking. They had a much simpler example. So much simpler than trying to think about domestic violence or plane crashes or stoves. They just said to their participants, suppose you sample a word. Just pick a word at random from an English text. So English language text, whether it's a book, a newspaper, whatever. You just got a big, long English language text and you sample a word at random from it. Does that make sense? Is it more likely that the word starts with the letter R or that R is the third letter? And what they found is that people overestimate the likelihood of words starting with R. If you pick a word at random from an English corpus, an English text, it's more likely to have R in the third position. There are just more letters that have R in the third position. If you play Wordle, that probably seems a little more obvious to you, right? But what their point was is that when people overestimate words beginning with R, it's because we don't really think of words by what letter is in the third position. We try to remember words by what letter they begin with. So you remember words, you think about all the words you can possibly come up with in memory, and you're thinking R. Can I think of a lot of R words? Well, you do think of a lot of R words because that's how we remember them. And so more examples come to mind for this than for this. Does that make sense? And so you've got more information. It's more available to you, even though it's wrong. And that's their main point. You can get more information, you can base your decision on it, but it's wrong in this case. It's not the right information. Just like it wasn't right to use only one example of Ray Rice to make an assumption about all NFL players, it isn't right to use all of the R words you can think of to make an assumption about the entire English language. They talk about how you can then attribute these things to groups. As you consider this is again from Kahneman and Tversky's research. Assume that Steve, the man Steve, selected at random from a representative sample. What's a representative sample? Everybody give me a definition of representative sample. If you're sampling something and it's representative, what does that mean?
Like the sample represents the diversity of characteristics in a certain population.
Sample represents a diversity in a certain population. So sample of random university students would be a younger age than a sample of people in London in general, right? So it's representative. So a representative sample of something. Individuals described as a neighbor as follows. Steve is shy and withdrawn, invariably helpful, but with little interest in something. What did I say there? I'm being covered up here. Little interest in people or in the world of reality. A meek and tidy soul. He has a need for order and structure, passionate for detail. And then you're asked to say, given two choices, is Steve more likely to be a farmer or a librarian? And what they found is that most people would say, what do you think's the answer that most people would say? How many say librarian? I mean, he's obviously more like a librarian because he sounds like a librarian. I mean, I don't want to make any assumptions about librarians not being interested in reality, but this is meant to evoke a stereotype that most of us might have about what somebody who's really interested in library science might be like. Librarians are not interested in the world of reality, but you can sort of get where this stereotype would be going. Does this match your stereotype of farmers? Probably not. What would be the attributes of a farmer? Anybody from a farming family? What are farmers like? I mean, they're probably interested in the world of reality. And they're probably have interest in people. And so what they suggest, and they suggest this is a heuristic, again, relying on things that come to mind. Most of us don't know a lot of librarians, but maybe we can think of some features. Most of us probably don't know a lot of farmers unless we're maybe from Listowel, Ontario, or some area in Huron County where there's a lot of farming. And so the resemblance of Steve's personality to a stereotypical librarian strikes everyone almost immediately, but equally relevant statistical considerations are almost always ignored. Did it occur to you that there are more than 20 male farmers for each male librarian in the United States? So if you just choose somebody at random, he's saying, it's more likely to be somebody involved in farming than in library science. Farmers are more prevalent. But most of us don't have access to that information, so we rely on features. And what comes to mind is somebody who we think of as being closer to a librarian. So we overestimate those likelihoods. All of these examples, I'm going to do one more longer example after this. All of these examples suggest ways in which our memory biases our judgment. Your memory is always trying to help you make decisions. And it's always trying to make your decisions fast and easy and not very resource intensive, which means that sometimes you make mistakes. And those mistakes are ones that line up with things like availability and representativeness. Last example, we're going to go through this final example. And if we get through it by 10:30, we'll probably take a break a little bit earlier than usual because that'll be sort of a natural breaking. About 2010, so about 15 years ago, this is a really prominent thing, which amazingly seems to be coming back in the United States. How many of you follow US politics or social unrest in the United States? I mean, it's kind of hard to avoid. Even if you have no interest in this sort of thing, it affects everybody's life in some way or another. I'm from the US, so I have family that still live in Pennsylvania, Ohio, and New York State. So I care, but I also care just because it's important to care about current events. It's kind of hard to avoid what's going on in the United States. And you're all probably aware that there's unrest in several cities in the United States based on clashes between local protesters and immigration custom enforcement agents, so federal law enforcement agents. So cast your mind back to 2010, if you can. You probably were paying less attention to geopolitical events in 2010, but this probably rings true to things that are happening in the US now, and maybe to a smaller extent in Canada. In the US, people believed that there was a war on cops. And what that means is they thought that there was many people in the United States thought there was an organized effort in the US to target law enforcement agents, to target local and state and federal police, to go after them, to somehow be waging a war on law enforcement. And that's what people said. Why the rise in police shootings? Law enforcement officers under siege. Under siege is not language you would use if there was just a little bit of conflict. Under siege suggests what? That's a metaphor for warfare, right? That means there's a coordinated coordinated organization to go after law enforcement. War on police sparks national crime wave. So here again, 2015, 10 years ago, violent criminals getting the upper hand. Because what was happening then, as happens now, is that when occasionally there would be a case of someone being shot or killed by police, there might be a reaction afterwards. There might be rioting afterwards. There might be demonstrations afterwards, which would then necessitate additional police to maybe quell the demonstration. And so one way to approach that is to say these demonstrations are part of an organized war on police. 58% think there's a war on police. I mean, this was not something that was limited to isolated news outlets. This is something that was pretty broadly believed in the United States about 10 years ago. Is it accurate? So let's look at some of the statistics from 10 years ago. Generally speaking, police officer fatalities in the United States go up and down. They go up in a couple of cases. They went high in the 1930s. What would have happened in the United States in the 1930s?
Question.
So the Great Depression and Prohibition, two really big things. People had no money and alcohol was illegal, which meant that there was a lot of crime because nobody stopped drinking. So when alcohol was made illegal in the US and Canada in the 1920s and 1930s, it was prohibited from being consumed and sold, which is kind of weird to think about, but there was a time when alcohol was illegal in the US and Canada. Making something illegal just makes it a crime, right? Which means there's going to be more law enforcement because they have to go after people who are still selling, consuming, etc. As a result, there were more officer fatalities because there was more police action. Officer fatalities went down, spiked again in the 1970s. In the 1970s was an era called the War on Drugs in the US. So there was an increased attention to go after drug enforcement. This is a time when cocaine first became a popular drug in the United States. So as these things go up, as police actions go up, police involvement goes up, which means probably police fatalities also go up. But generally, they've been going down, and around the time that people thought there was a war on cops, officer fatalities in general were declining, with the sole exception of police officers who were killed in the terrorist attack in New York City on September 11th, because there just happened to be a lot of people who were killed at that time, first responders. That's a one-off event. Generally speaking, police officers were not dying in a rate that seemed unusual given the circumstance. Fatalities per million population continue to decrease through time. Fatalities per 100,000 for different professions. Police officer is not necessarily the safest profession. You do put yourself in dangerous situations if you're a police officer, whether you're a London police officer, OPP, RCMP, or in the US, whether you're state police, federal police, local police. There are going to be times when there's a dangerous situation, right? Because you're a law enforcement agent, and law enforcement is a dangerous profession. It's not exceptionally dangerous given other things. Logging and fishermen are generally much more dangerous in terms of fatalities. Logging is a very dangerous activity. Crime rates in the US have declined since the 1990s. So around the time that people thought there was an organized crime wave specifically targeting law enforcement, crime rates for all crimes have been decreasing in the US. So it seems to be the case that around the time that people believed there was a war on cops, crime had been decreasing over the last 10 to 20 years. Fatalities among law enforcement decreasing over the last 10 to 20 years. So it didn't seem to be accurate. So one or two high-profile events might make it seem as if it's the case, but it doesn't seem to line up with reality. Even the New York City Police Department in 2014's annual firearms discharge report, all of this is publicly available information, suggests that officers are not shot and killed by subjects very often. Many years, nothing happens, zero. Occasionally, you might get one or two. And that's true also for police officers shooting subjects or suspects. It also, although it's unfortunate when it happens anytime, it doesn't happen very often, even in New York City. So it happens, but it's not an especially prevalent case. Every year since the 1970s, it's tended to decrease. So the belief by most Americans that in the mid-2010s that there was a war on cops seems to be a case of availability bias. One or two cases where law enforcement might have been shot or killed in the line of duty, and then a poll right afterwards is not accurate. But what happens when you do a poll and publicize the results of that poll? That also becomes part of the information. In addition to seeing that there was an actual case of a police officer being shot, the more you see the results of those polls and the more you see information about from various news outlets and from various opinion outlets that this is a problem, that starts to become part of the memory itself. And so we'll see that we'll come back to this later today. That's one suggestion for why in the US and to a lesser degree Canada, but certainly in the United States, for increased polarization. When a single event can be perceived in different ways by different people. And most people's belief in what they're seeing and understanding doesn't change. Because most of us, especially this is certainly more true in the US, tend to receive news from a very small series of outlets, right? You tend to see the things that already align with what you believe. How many of you actively read a mainstream news outlet or any kind of news outlet? How many of you actively keep up with current events? How many of you sort of absorb current events through just what's going on around conversation or social media or discussions or group chats or TikTok or whatever? So it's probably a combination of both, right? And if you rely on anything like that, if you rely on reels or stories or social media or X to get your news, you're probably going to get news that aligns with the things that you've read before. That's how most of these algorithms work. And so you'll continue to get news that fits with things that you just read. If you read something that you agree with, you'll get more news that more stories that looks like stuff you agree with. And so it's going to likely increase that availability bias. And so you might have cases where one large group of people in the US or in Canada or anywhere might believe something. And another large group might have a completely different belief and lots of evidence to support that belief because they're not getting it from anywhere else. You're getting things that are already biased through the way these algorithms work. Does that make sense to everybody? So it's just going to, it's likely going to enhance this availability heuristic. Memory affects your thinking process, all of our thinking processes, for better or worse. I mean, there's no way around it. Your memory is how you think. That's what you base your decisions on. Risk, any kind of risk assessments, whether or not you want to do something that seems risky or not risky, is assessed via memory for events. Decisions are made according to those risk assessments. And the problem is, for most of us, memory is not very reliable. Our memories are good at remembering things. They're just not good at being accurate recorders of what actually happened. Most of us have memories that work flawlessly for making decisions quickly. We don't have very good memories that record what just happened. What was the first slide that I showed today? Anybody remember? The WPA slide. How many of you remembered that? I mean, like it just happened. Just happened 30 minutes ago, and I could barely remember it. In fact, I wasn't 100% sure. Most of us don't have very accurate memories. You sort of just float through life, kind of mostly remembering some things and just hoping that it's right. And as soon as somebody says something to shape your memory, it becomes part of the memory itself. Couple more slides and then we'll take a short break. So let's refer to this as the illusion of truth, because we don't really know what's true and what isn't true. Because as soon as something has happened, it's in the past. And the only thing you have is your own memory of it. And if your memory is flawed, if your memory is malleable, if it's shiftable and changeable, then you don't know what happened. You just know what you think you thought happened. And that's not the same as something that actually happened. Repeated exposure to false or ambiguous information increases the likelihood of later recalling that information as true. The more you read something, the more likely it is that you're going to remember it as being true because you remember seeing the fact. You just don't remember if the fact was correct or not. Even if you know the fact is incorrect, if you see it a lot of times and then later you come back to it, you don't remember whether or not it was true. You start to remember it as just being something that you remembered. And that starts to seem truer. Rumors, political statements, urban legends, presidential tweets and posts, and so on. These illusions persist because our memory is fallible. Remember one of the challenges to our thinking process, this idea of incomplete evidence. We always have something missing. There's always going to be some kind of piece of information missing. Even today's lecture, you probably forget to write a few things down. Once you've forgotten to write them down, you don't go back and check the slides or the lecture, it's almost like it never happened because maybe you didn't record it, right? So that's incomplete evidence. When information is not complete, you just use the information that's most available. If we make the assumption that your memory doesn't encode everything, which is what we're going to talk a lot more about in the next half of this class. So if you can assume that you're missing information, that means you're always going to be making decisions, judgments, and thinking and reasoning outcomes from incomplete evidence. The evidence that you do have is what's most available. So even if this available information is not accurate, we still tend to trust it because you do trust your own memories. Why wouldn't you? If you stop trusting your own memory, then you have other problems. But for the most part, we do trust what we remember because it's the only thing we have. We're sort of designed and we've evolved that way. So last quick example, we're not going to go through this because I think how many of you have seen this example before? How many have not seen this example? Let's go through this example then, because it looks like more of you haven't seen it. Let me explain what you're going to see, and then we'll watch a short video, and then we'll take a break, like a less than a minute video. This is a study from 1998, but it sort of started a whole line of research, which is still pretty strong, which all comes back to the idea of either change blindness or inattention blindness. And the underlying idea is that we don't pay attention to everything all the time. I mean, that's generally true. You can't pay attention to everything all the time. You're always going to be missing something because why? We're multitasking. The idea of inattention blindness is that sometimes really big shifts happen. But if those big shifts happen and you're not paying attention to them, you just ignore them entirely. And what's going to happen in this video is this guy here is one of the experimenters, and this guy here is one of the experimenters. So two experimenters and an old guy with white hair. And this is on the campus of Harvard University, where Dan Simons, I think, was an assistant professor at the time. And so experimenter number one asks this old guy for directions. We assume he's an old professor. Why? Because he looks like a professor and he's on a university campus. So we can have some general representativeness heuristics. Old professor. How many of you have asked an old professor on campus for directions from time to time? I walk around on campus and sometimes people ask me, where can I find this building? Just last week, an Uber Eats driver was asking, somebody had ordered something from Tim's, which seems incredibly lazy, in my research building. They had Tim Hortons lunch from an Uber Eats. He says, is this the Western Research Building? I said, yes, the Western Research Building. So somebody ordered their lunch from Tim's to the Werb building. Again, incredibly lazy. So this happens. Sometimes if you're walking around campus, people ask you for directions. This guy asks for directions, and here he is pointing. Yeah, just go down this way. Meanwhile, two guys carrying a big wooden door walk in between them and interrupt. He's like moving back. And what you can see is guy who starts asking instructions switches places with one of the guys carrying the door. And so that once the door moves through, old prof is talking to an entirely different human being that doesn't notice. So the person in front of him in real time, in real life, has exchanged for an entirely different person, and he has no idea. And this isn't just because he's a prof and he thinks all undergrads look the same. That could be part of it. But this has been replicated in lots of different settings. Now, again, 1998, it's a long time ago, but that's when I was in grad school. And when I first read this study in grad school, my mind was kind of blown. I was like, do you mean that things could change right in front of me in reality and I wouldn't even notice? So then like, what am I even doing with my life? Something could have changed in front of me and I wouldn't even know. Like I'm talking to a different person and I would have no sense of what had happened. Reality could change right in front of you. And if you're not paying attention to it, you won't notice. You won't even notice. And this is like pretty trivial. This has a lot of implications for what you use your memory for. Let's watch the video really quickly and then take a short break.
The man on the left.
The Door Study by Dan Simons.
The door study.
That's what he calls it.
This video shows a participant from a 1998 study by Daniel Simons and Daniel Levin. Watch what happens as the unsuspecting pedestrian provides directions. The young man on the left is one of the experimenters. He has approached the white-haired man and asked for directions. Watch closely as two people carrying a door pass between them, and the first experimenter is replaced by someone else.
He has no idea. Talking to a totally different man. And he's just happily going around with his man.
Like many of the people in the study, the pedestrian was entirely unaware that he was talking to a different person. Approximately 50% of the people approached in this study didn't notice when the person they were talking to was replaced by someone else. This study was among the first to demonstrate that change points can occur outside of the laboratory. This video is from research by Daniel Simons and Daniel Levin and is copyrighted. It is available for use in talks, training.
And it's available on YouTube as well. Thanks. So let me just go back to this last slide here and then we'll sort of take a quick break. So again, to me, that was really surprising when I was a grad student. I was later a postdoc at the University of Illinois, and Dan Simons had joined the faculty there around the same time. And he did a lot of other research around this idea. One of the experiments I remember him telling us about was one where, how many of you have participated in lab experiments in intro psychology? So you go to the lab and often they ask you to fill out a consent form. Maybe they're having you do forms or they're having you do an experiment on a computer. And the experiment went like this. You walked into the lab and there was somebody standing at a desk, like a reception desk. And they said, oh, hi, you're here for the experiment. Let me get your consent form. They went down to get the consent form and a different person stood up. And about 50% of the people didn't know this, that a different person had just come up from the desk and handed them the consent form. That was the experiment. Everything else was something else. So again, if you're not paying attention to little things, you're going to miss little things. But if you're not paying attention to big things like the guy in front of me, and he changes, it violates your expectations. First of all, you don't expect people to change right in front of you. So it's not something you're waiting for. But even when it does happen, it should be noticeable. But our minds and our memories tend to just gloss over that. We just assume, well, this is who I've always been talking to. Reality has changed in front of me, and it's the same as it was before, because you don't expect reality to change in front of you. Okay, so that's the problem with memory. All of our decisions are based on our memories, but our memories aren't very good. They're good at recording things. They're just not good at recording things accurately. They're good at biasing and influencing our decisions, but they're not always good at maintaining a stable representation because they shift and change with time, and sometimes you don't pay attention. Let's take a quick break, and then we'll come back and talk about why this is the case. So it's about 10:38, so maybe 10, 12 minutes or something like that, and then we'll continue when everyone's back.
Angular. Yeah. Just starting now. I don't know, it's kind of like look like this.
All right, it kind of looks like most everybody's back. Obviously, I have no way of knowing if everybody's back because I don't remember what changed. You could be in different positions, but I wouldn't remember. So I think everybody's back. It kind of seems like it's roughly the same number of people. Speaking of memory, is it unusually cold in here today? Was it unusually cold last week? I don't remember. In fact, I thought I remember it being a little warm last week. Okay, well, I'm glad to know that it's not just me, but it feels really cold in this room. And I'm not liking it. I didn't like it outside, but I kind of wanted it to actually be indoor temperature, but I feel like it's almost not indoor temperature right now. So that's okay. Everything is broken, as I'm sure you probably noticed. There's always, any given day, there's something that isn't working right. And it seems like our classroom heat is that thing today. Okay, so let's talk about different kinds of memory. And we'll go through this kind of quickly, mostly because this is covered really extensively in the textbook. A lot of you have covered this in cognitive psychology, and you've all covered some of this in intro. So I'm not going to go through a lot of this in great detail, and then we'll come back to some memory errors. There's a good chance we'll be able to finish today's lecture by about 12 o'clock today. And that's going to be sort of my goal, is to finish by 12. Okay, so that goal will be more achievable if I can stop talking about the goal itself and also get this started. All right, here's a big picture of all the different kinds of memory that you might want to consider and how they might influence behavior. So think of this as a large, non-specific model of human memory, where we assume that we've got inputs, whether it's visual inputs, auditory inputs, tactile inputs, etc. Stuff that's coming into your sensory system. So this is sensation and perception over here. And that you've got a short-term or a working memory system, which we'll talk a little bit about. And this is kind of your short-term awareness of what's happening. As you read things or as you see things, they're aware in your memory. You're aware of what you're seeing. And this is sort of a constantly updating working memory store. Disruptions to working memory will mean that you will miss information. Disruptions of perception mean that you miss information. From this input, sometimes you can have direct access to a procedure. When I say direct access to a procedure, we'll talk about this as an associative memory. It's the kind of memory where you don't even need to think about what you've seen to react to it. So this might be like a operant or a classical conditioning example. So sometimes a specific thing, specific stimulus, something you see, activates a behavior even if you're not aware of it. Very procedural. If I were to toss this remote out to somebody, you'd catch it without even thinking about what you were doing, right? It would just be sort of an automatic response. That's what I'm talking about there. So some of these inputs directly access your procedural memories. In other cases, short-term memory can be transferred to different kinds of long-term memories. So this is that representational system. Things that you use to remember facts and events might be divided as declarative memories, which can be episodic in nature, memory for specific things that happened in the past to you. That's an episodic memory. It's a memory for an episode, a thing that happened. Episodic memory is also future-oriented, a thing that might happen. You can think forwards and backwards in time using an episodic memory approach. You also have semantic memories. These are memories for facts that don't necessarily correspond to a specific event. So all the things you know, you maybe don't have a specific event. You don't remember when you learned a particular fact, you just know facts. So all of these are part of your long-term memory, and they influence your decisions, your planning, your problem solving, and your reasoning. And those things go back and forth. As you solve problems, you update your memories. As you make decisions, you update your memories. You remember if it was a good decision or a bad decision. And you try to use all of this to assist with your daily living. Spreading activation through similarity is how you access the memories that you need. So keep this in mind. We'll come back to this slide again as sort of a general overview of all the kinds of memory that you have, from the shortest to sort of the longest term memories for things that have happened over and over again, which might be semantic or fact-based in nature. Memory functions by encoding, storage, and retrieval. So most of what we'll talk about deals with taking some information and converting it into a representation that you can store. Now, when I say storage, I don't mean a place necessarily, because all memories are stored in your body. right? I mean, they're stored in your brain. They might be stored also in other areas of your body outside your brain. You might have aspects of a memory that are sensory in nature, that might correspond to a specific position of your hands. If you're playing piano, when you sit down at the piano, you remember how to play the piano, right? So memory isn't just in the brain, but it's mostly in the brain. But it isn't necessarily a particular place in the brain. So when I say store your memories, I don't mean that you're storing them in a box. I just mean that there's something there that can be retrieved later. In other words, reactivated. These are metaphors that are kind of physical in nature. Encoding, storage implies putting something in, retrieval implies bringing something out. But that's just a metaphor for talking about memory. Biologically, what it is taking the information that you perceive and activating a state of neural connectivity. Storage means being able to strengthen that neural connectivity. And retrieval means being able to recreate the same neural connectivity. So we're using metaphors of putting things in and pulling things out, but what we really mean are reactivating neural connectivity. Does that make sense to everybody? So memory intentions are hypothetical construct. You can't really see a memory. You can see activation patterns in the brain with functional magnetic resonance imaging or different kinds of brain images. But you can't really see the contents of a memory very well. So you can't really see what's in somebody's thoughts. So we tend to see what's at the beginning and at the end. We see what you pay attention to, and we see your behavior afterwards. Those are a lot easier to measure than what's going on in the brain itself. Memory is likely kind of unitary in the sense that it is all taking place in a neural architecture. But lots of kinds of memory seem like they're different systems entirely. So I showed you on that big overview, short-term memories and different kind of long-term memories. So although memory is all part of a unitary system, it's all part of a neural representational system, there are different kinds of memories that are based on the way in which the information is initially stored and the way in which it's retrieved that make it seem different. So let's talk about them very briefly. We have sensory memories, which are less than a second. So a trace of information that is perceived exists longer than the actual stimulus. So if I were to flash a screen, on the screen some letters, those letters would retain the information from those letters in a visual representational system. So a visual system before you even know what the letters are. So there is some kind of sensory storage. It's very brief, it's less than a second. You also have a working memory span. Your working memory span is what you're constantly updating. It's what you're actively aware of. If you're listening to me, you're working through your working memory. You're understanding the words and the ideas by keeping some of them active in a working memory system. So when you're watching something, you can keep track of continuity in visual inputs by tracking it in this working memory system. So the way to think about it is as if it's a constant, it's a short loop of some kind, constantly updating with new information. Information comes in, you can process it a little bit, and then offload it to other mental systems, activate other representations. What I've said here, we'll go into a little bit more detail, but your working memory, at least for verbalizable facts, seems to be about 7 things. Most of us can remember about 7 facts in a working memory system, give or take. So 7, maybe 9, sometimes maybe 5. So 7 plus or minus 2 seems to be roughly what we can remember at any given time. 7 numbers, 7 words, 7 facts, 7 people. There's a point at which you can't remember everything in a list unless you encode it in a different way. You can remember a lot more than 7 words if you remember all 7 of the first words in a single sentence. So then you can remember 7 sentences. You can remember a lot of things if you put them into chunks, but if it's unrelated, if there's no additional knowledge, you can remember about 7 letters or about 7 numbers at any time. Which is why, for practical reasons, when you have to enter a number for multi-factor authentication. It's not a 30-digit number, right? It's like a 7 or an 8-digit number that you've got to remember briefly. I mean, sure, you can copy and paste it, but sometimes you actually do have to remember, right? So when you have to remember something, you can remember that short piece of information until you don't need to. So when you have to activate something, how many of you do this on a regular basis? You've got to remember that short multi-factor authentication number to put in somewhere else. And as soon as you've entered it in, you no longer remember it, right? You've offloaded it by putting it into the text box, and you don't remember the number anymore. It's completely irrelevant. So you can remember it briefly, and that's it. For your long-term memory, there really isn't a limit for what you can remember. You can continue to learn new things your entire life. You will also continue to forget things for your entire life. So there really isn't a limit to what you can remember, but there's lots of confusion that can happen along the way. So in the textbook, just briefly we'll talk about this. I discuss a working memory system. This should be familiar to most of you if you've taken intro psychology, should be familiar if you've taken a cognitive psychology class. But the general idea is this working memory system, which is what we're constantly updating. It's what we're consciously aware of when we're going through life, is that you have sound and word-based information separate from visual spatial information, separate from time-based information. That those three kinds of information are encoded separately. They're encoded by systems that are closely related to the perceptual inputs. One of the reasons that you can see a separation between visual spatial information and auditory or word language-based information is that that information often comes into different sensory modalities. Vision comes in through your eyes often, and language comes in through your ears. So it isn't completely separate, but they do tend to start in separate neural systems. And so this working memory system assumes that you take advantage of that separation so that you can maintain visual information separately from auditory information. You can also track when things happen separately from the visual characteristics and the auditory characteristics. But you have to integrate them. At some point, you can't keep all visual information separate from all auditory information. And so you have a way to centrally allocate resources. This central executive we often refer to as executive functions. So you're probably familiar with the idea of executive functions. So these are the kinds of behaviors that allow you to inhibit information, or the kinds of behaviors that allow you to allocate resources, pay attention to some things and not others. Most models of working memory, including this Baddeley model, assume a role for either a central executive or more generally defined executive functions. Executive functions are usually defined domain general characteristics such as task switching, inhibitory resources, and selective attention. So the idea of switching between inputs, that's an executive function. So if you want to pay attention to the auditory information and switch over to some visual information, that requires some effort. So that's what this central executive or executive resources are. They take time and they take mental resources. And we can measure them separately. Task switching is the act of switching attention from one behavior to the other. Remember from 2 lectures ago when I talked about brain rot, and I said that one of the costs is having to switch, paying attention to one thing and then switching to something else. Of course, you're going to lose some of that time. And as you probably saw from the change blindness, if you switch from one source of attention to another, something could change and you wouldn't notice because it would happen while you were switching. But there's also the cost of switching itself. Just the effort that it takes to switch from one source of attention to the other causes you to, takes a certain amount of time. And it means that's time you can't spend thinking about one thing. Task switching operates at different levels of cognitive and cognition and across many domains, which is why it seems to correlate with other measures of cognition and performance. So a lot of ways we can measure these executive functions. One is what's known as the Wisconsin card sort task. And a Wisconsin card sort task, how many of you are familiar with a Wisconsin card sort task? So I think we talked about this briefly in my cognition class, but otherwise you probably wouldn't come in contact with this idea. So Wisconsin card sort task is an experimental procedure that can also be used to assess task switching. And what you're given are a series of cards. And this looks like kind of a fun game, frankly, a matching game. It's really easy for anybody, even young children, or people with cognitive impairment or even brain damage, to be able to do this to some degree. You've got some comparison cards. You've got a single red triangle, 2 green stars, 3 yellow crosses, and 4 blue circles. And then you're given a target card, and you're asked to put it on one of the 4 piles. And then you're given feedback on whether your decision was correct. And so suppose you decide, I'm going to match it to this card here. The experimenter or the program that you're playing with would say you've made the right choice. It would give you correct feedback. What you should take from this is that your dimensional sort in this case, the thing you need to pay attention to is shape. So that when you see 2 triangles, doesn't matter what color they are, how many they go on the triangle pile. And that means that on your next trial, if you see a cross, you put it on the cross pile. There's 1 green cross. You ignore color, you ignore number, and you pay attention to shape. Does that make sense? What happens in a Wisconsin card sort task is that once you've figured out the rule changes. After a certain number of correct trials, what happens is that you make a correct decision. So here's a person who's made a correct decision. They've put the red crosses on the pile there. Here's one they've made a wrong decision. Now they made a correct decision. So at this point, the participant should have decided that it's a color rule, which is what this C stands for. So they figured it out through trial and error. Correct, not correct, correct. So they only make a lot of correct decisions. They've got color, 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 and color. Now they've got another color. And then at some point, the rule switches. After a certain number of correct answers, they put a green 3 triangle on the green pile, happily assuming that color is the rule. And the rule has changed. Now, when they apply the color rule, they get wrong. And you'd be really disappointed with yourself. You'd be like, I thought I had this figured out. I've been going along happily just applying a color rule, and now it's not a color rule anymore. You got to be kidding me. And so you get wrong. You get wrong again, and this is a perseveration error. It means that you're continuing to make wrong decisions on the rule that you had just learned. Now, everybody's going to get one wrong answer, right? I mean, in this, even if you're really good at the Wisconsin card sort task, you know that at some point it's going to change. You can't predict what that change is going to be. You're just going to have to notice it. And what most adults with well-functioning brains would do is that after 2 or 3 mistakes, they would say, okay, I guess the switch has happened. Now I got to completely forget what I learned already, and I got to figure out what the new rule is. It takes 2 or 3 trials. It doesn't take very long to figure out what's going to happen. But if you were a young child, you might go a long time before you switch. In fact, you might even know that the rule is switched. You should know that the rule is switched because you're getting error signals. But you keep choosing color because that's what you learned. If you're an older adult with brain damage to the frontal cortex, you would be far more likely to make those perseverative errors. And so what this task measures is a breakdown of executive functioning. Individuals with high levels of executive functioning make the switch quickly. Individuals with impaired executive functions, and in most cases this means really young children or people with particular kinds of damage to a prefrontal cortex, would perseverate on those errors. They would continue to make mistakes. Does that make sense to everybody? So this is an executive function. It allocates resources. It switches away from something and tries to learn a new rule. Inhibition is another rule. So you probably know people. Do you have friends who are relatively less inhibited? People with low inhibition are more likely to take risks. Alcohol reduces people's inhibitions. They're more likely to take risks when they've consumed alcohol. Young children, people who are young adolescents are more likely to engage in slightly more risky explorations because they have lowered inhibitions. People with damage to a prefrontal cortex more likely to engage in uninhibited behavior. Now that's inhibiting behaviors, but you also have cognitive inhibition. Cognitive inhibition is not paying attention to something that doesn't need to be paid attention to, actively ignoring something that you don't want to pay attention to. When we talked about the effects of smartphones, we talked about how you might need to ignore the phone on your desk. And that if you can't, it's going to cause you to lose something because you're going to look over at it, look at it for a second, and then look back. If you can ignore things, you're more likely to inhibit them. You've got more attentional resources available for the task that you want to do. We can measure this with something called a flanker task. Does anybody know what a flanker task is? Flanker task. We're going to present you, the subject, with a bunch of arrows that point in different directions. And your job is to pay attention to the middle arrow only. That's why it's called a flanker task, because other arrows are on the flanks, meaning the sides. So your job is to pay attention to what's in the middle, and you press the button that's on the right or the left. So imagine being in this experiment and pay attention to the middle arrow. You don't have a button and you don't need to raise your hand, but just play along with me for a moment. Sit and watch these and try to press an imaginary button with your right hand when the arrow points to the right, and an imaginary arrow with your left hand when the button points to the left. Okay? Let's go. So we'll just do a couple of quick trials, middle arrow only. So we go right. I said raise your right hand, but just imagine pushing your right hand. You go left. Ready? What we would notice is a slowdown on this trial. How many of you took just a few seconds longer for this one? Could you notice that this one is a little bit trickier? It should be, because this one has nothing to distract you. It's just an arrow, real simple. This one, the arrows all point in the right direction. You got a lot of information saying left. This one, you've got a lot of information saying right, but you're supposed to go left. So what we can notice is that individuals who are more sophisticated or higher levels of executive control, the ability to control their attention, are less likely to be thrown off by this trial. Their reaction time differences between the mismatched trial and the matched trial are going to be lower. Individuals with with lower levels of executive functioning are going to show bigger reaction time differences. In other words, it's going to be a higher slowdown and possibly more errors on trials like this. I guess I don't need to keep doing it because I already made the case here, but apparently I threw in some extra trials anyway. And when does this end? Oh, come on. All right, so congruent trials are ones where everything lines up. Neutral trials are ones where there are no distractions. And incongruent trials, as you can see, the thing you pay attention to differs from everything else. And so that's what it means to measure your inhibition, your inhibitory control. High levels of inhibitory control, you're less likely to see a difference between congruent and incongruent trials. Lower levels of inhibitory control, which you would see in young children, older adults, adults with brain damage, or yourself if you were intoxicated, or yourself if you were just really tired, or yourself if you were in situations where something else was robbing your attention. If, for example, we did this task at the end of class, but everybody had had an enormous cup of coffee at the beginning and really had to go, your inhibitory control would start to go down because you're paying attention to the fact that I really got to go. I really have to go to the washroom right now, and it's getting desperate. And that also requires attention. That also requires your cognitive resources. If you're really stressed in situations, your inhibitory control goes down. More likely to make mistakes. If you're paying attention to something on your smartphone, of course, more likely to make mistakes. Does that make sense to everybody? So that's your inhibitory control. These executive functions, this is just a snapshot from a paper from an author named Adele Diamond, who's a researcher who studies a lot about executive functions and development, suggests that they make possible mentally playing with ideas. In other words, to consider lots of ideas. If you want to reason through something, if you want to make a decision where you have to consider two or more things simultaneously, you need to be able to have some executive control. If we talked about chess playing on the first class, playing chess requires a high degree of executive function because you need to consider lots of variables simultaneously. Arguing with someone, and I don't mean arguing just by shouting, I mean having a discussion where you're trying to persuade somebody, like a debate, requires a high degree of executive control because you need to keep your ideas straight and the other person's ideas straight. Takes time before thinking, meeting novel, unanticipated challenges, resisting temptations, and staying focused. Core executive functions are inhibition, interference, working memory, cognitive flexibility, all of these things. And these are going to come up throughout this class. The idea of flexibility, the idea of being able to consider multiple alternatives. There's a developmental trajectory. As you develop cognitively from young childhood to middle adolescence to older adolescence to young adulthood, which is where most of you are, your executive functions are fully developed. 5 years ago, they weren't. 10 years ago, they definitely weren't. As you get older, your executive functions start to degrade. The importance of social, emotional, and physical health for cognitive health is also important because lack of sleep. How many of you are suffering from a lack of sleep this week? I mean, on any given day, there might be a day when you feel like you're not fully rested. Lack of sleep reduces your cognitive control. It reduces your executive functions. So when you're really sleep deprived, you're not going to perform as well on these kinds of tasks, on things that require your ability to pay attention. Lack of exercise can impair executive functions. They can be trained and they can be improved. And so in this paper, in Diamond's paper, she suggests that all of these things, and this is similar to our memory plot, suggesting that we have inputs. Executive functions control our working memory. They control our inhibitory control. They oversee our inhibitory control. There's some degree of cognitive flexibility, the idea to think together certain kinds of ideas simultaneously, all have an impact on these higher level executive functions. Higher level executive functions, higher level cognitive functions are things like problem solving and planning and reasoning. So keep this in mind when we come back to talk about reasoning in a few weeks. When we come back to talk about problem solving in a few weeks. The higher degree of executive functioning is going to correlate with higher performance. And I don't just mean executive functioning as a trait. That does differ as an individual difference among people. Some individuals have higher levels of attentional control than others. But mostly I mean it as something that varies within you from day to day, like when you're sleep deprived, or at the end of today's unusually long lecture. Despite the fact that it isn't long, it probably feels really long right about now. Or when you're just tired at the end of the term, or when you're really cold, for example, and you're paying attention to how cold you are, eventually that might start to interfere with your executive control. It's bad enough being in this lecture when it feels like it's about, does anybody have the ability to take the temperature? Does anybody have like a thermometer available to them? I'm going to guess it's about 18 degrees in here. That's kind of cold. 18 degrees in the summer would be great inside because it would feel like the air conditioning is on. But 18 degrees right now inside feels kind of cold. It might even be colder than that. If you were taking an exam though, it would be awful to be sitting in here freezing while you're taking the exam. So imagine having to spend most of your day, if you were sleeping outside in cold weather like this. Maybe you wouldn't be making the best decisions all the time. It'd be really hard to consider multiple perspectives when you're cold and hungry all day long. So all of these things can vary within an individual and interfere with your ability to make good decisions, to solve problems, because you don't have the cognitive resources. Okay, let's talk about working memory rehearsal. We'll talk about storage, and then we'll talk about memory errors. Is everybody with me so far? Okay. Anybody need another quick If you need to stand up and stretch to warm yourself, feel free to just go ahead and do that. It won't bother me. So in your working memory, things decay, meaning that you can't keep something in your working memory forever without trying to. Stuff just fades, just like when we gave the example of the multi-factor authentication 7-digit number. You see it, you write it down, it disappears. You don't maintain that. You don't have a memory for what that number is forever. If you didn't say it to yourself, it would definitely disappear. So if you saw if you saw on your text what the number is that you got to put in, you say it to yourself and you try to repeat it to yourself a few times until you write it down. If you don't say it to yourself, it's definitely going to disappear. So we're going to call that maintenance rehearsal. You can remember that digit kind of indefinitely as long as you keep saying it to yourself. If you get the prompt here and you need to enter it into a different machine, you could probably do that by saying it to yourself over and over again.
Oh, same thing as subvocal rehearsal.
Subvocal rehearsal is a great way to describe this. Subvocal rehearsal means that you're not saying it out loud, you're just using your inner voice and you're rehearsing it subvocally. You're saying it to yourself silently, which is what most of us do when we want to remember something really short and not very meaningful. This relies on the phonological loop of the working memory system. But most of us need to remember stuff longer than that. We don't need to remember just a lot of digits to put into a text box and then forget about them. Most of us need to remember stuff so that we can use it later. And that requires a different kind of rehearsal. Maintaining it in working memory only maintains something or keeps it in your memory for as long as you rehearse it. Now, yes, you can learn facts, which you probably did when you were learning different kinds of terms or vocabulary for tests. You can sometimes learn things by just repeating it over and over again, right? You can eventually learn something. That's probably how you learned your phone number when you were a young kid. It's probably how you learned your parents' phone number. How many of you know your parents' phone number without looking at your phone? That's pretty impressive. I don't know any of my children's phone numbers, despite the fact that they're only one digit different from mine, because it's already in my phone, right? I can remember my dad's phone number that he doesn't even use anymore because it was the one that I had when I was a kid in the 1970s. It's a dead number, or somebody else has it. I don't know who has it. I know the phone number I grew up with because I said it enough times, but I don't know what my dad's cell phone number is, even though he's probably had that for 20 years, because it's different from the one I memorized, and now it's just programmed in. I've cognitively offloaded all of that. So I know my wife's phone number, I know mine, that's pretty much it. I don't know anybody else's, because why should I? I've got it written down somewhere. So when you want to learn a fact, you got to elaborate on it. You got to connect it to things you already know. The only way to really learn something is to elaborate, to connect the thing you're trying to learn to other things you already know. It requires more effort to really understand something, but you usually retain it for longer. And this goes back to this idea of elaborative encoding. Also helped to uncover a really interesting finding in the memory research, memory literature in the 1970s, known as levels of processing effect. So the level of processing effect suggests that there are different ways to pay attention to the same information, and some ways allow for better recall than others. This is useful because it helps you remember things better, but as we're going to see in a few slides, the same idea of elaborative rehearsal and levels of processing can also encourage memory errors. So good memory and bad memory are sometimes related by the same kinds of processes. But let's talk about Craik and Tulving's 1975 experiment. So they did a lot of research in the 1970s. Craik and Tulving are both U of T. It would be fair to say that memory research in the 1970s and 80s in Toronto helped to really change the way that most psychologists think about memory. Prior to Craik and Tulving's work, it was generally assumed that in order to strengthen your memory, you needed to rehearse things. More exposure meant better memory. What Craik and Tulving said is that's not always true. It has to be the right kind of exposure. This seems really obvious now, but when Craik and Tulving discovered it, it changed the way most psychologists think about memory. They asked their subjects to learn a list of words. So this is what all memory researchers started doing in the 1960s and 1970s, ask people to learn things. They just asked them to learn a list of words. And for each word, you had to think about the word and answer a specific question. So this is different than just saying, here's a list of 30 words, memorize this list and recall it. Sometimes you might be asked to remember words by answering a question that focused your attention on the structure. Is it in capital letters or not? So in this case, the target word that you were trying to learn in the list was the word king. There's one in capital, there's one in lowercase. Obviously, you could do this. You could answer this question without really reading the word. You don't even need to know what the word is. You could just kind of blur your eyes and look for a capital letter and respond yes or no. So what you're encoding is the structure. You're encoding capital, lowercase. In the phonemic condition, they asked their subjects to answer a question about whether or not the word that you needed to learn rhymed with something else. In order to answer the question, you needed to read the word, at least to yourself, so that you knew what it sounded like, so that you could say yes or no, does it rhyme with this other word? In the semantic condition, you had to think about what the concept was. What does this word actually mean? Now, in all of these cases, you can ask participants to learn the list, or you can just ask them to remember to just do the questions and not even expect a memory task later. But regardless of what you ask subjects to do in terms of expecting a memory test, if they focus on the meaning, they remember more words. If they focus on the sound, they remember fewer. And if they focus on the structure, they remember the least. So something about paying attention to the concept activates other things. So if you're thinking about king in this case as being a type of royalty, you think about other aspects. And so you activate a whole cluster of other concepts which become part of the context. That becomes one of the other memory cues. Now you've got a lot of stuff that's been activated in your memory all around the world, word king. If you're just paying attention to the structure, you barely think about the word at all. You just think about the letters. And so when it comes time to remember those letters, or those words later, you're less likely to recall them. In fact, you may not have even remembered seeing the word because you weren't paying attention to what it meant. Does that make sense? Tulving and others, Craik and Tulving and others, also suggested that memory can be divided by content. So we've talked about short and long-term memories. We've talked about encoding in different ways. They also suggest memory is either semantic in nature or episodic in nature. So I'm not going to go into great detail, but we'll talk a little bit about this. Semantic memories are those memories that are fact-based. Anything that is a general fact that you know is a semantic memory. Memories that are related to things that happened to you, like what you had for breakfast today, where you were for vacation last year. Sometimes you can think about what you did a few years ago. Those are episodes. Those are things that happened to you personally. Endel Tulving describes episodic memory as being a kind of mental time travel that lets you go back in time and think about things that happened. And it also lets you go forward in time and think about what might happen. That's kind of interesting because it suggests that your episodic memory system doesn't have to actually correspond to something that happened at all. To just say that episodes are past, things that occurred to you, and that you would remember facts, that's one thing. But if episodic memory also allows you to think about things that haven't happened, then it really suggests that your episodic memory is pretty flexible because you can use it to think about things that might happen. In other words, it's a system that you can invent. You can invent memories. You can invent memories for things that might happen. You can also invent memories for things that didn't happen at all, but you thought did, using this episodic system. That's going to be the source of a lot of memory errors, which we'll talk about in just a few slides. Memory is also non-declarative in nature. So declarative are things that you can say that are in your memory. You can declare their existence, whether it's through saying you know something or saying something happened. That's declaring it. Procedural memories are motor type memories, memories for rules or memory for behaviors, things that you might not be able to explain verbally but still exist. You can remember things intentionally. You can try to remember things. So memory differs in terms of how it's encoded. A lot of us try to remember things, whether it's trying to remember a list of words or trying to remember things for an exam. You're really trying to remember something. You're having a conversation with somebody, you want to remember what they said, so you try to remember that information. But we also remember a lot of things incidentally, things that we never tried to remember at all. It just kind of happens. You are exposed to it, and you remember it without even trying. There's probably a lot of things you've learned incidentally. You could probably learn to recognize your friend's handwriting, but you probably never sat down to think about what your friend's handwriting looks like. I'm sure you could recognize your own handwriting from someone else's, but you never really thought about trying to learn about what your handwriting looks like. You remember the lyrics to songs without really trying. You can remember songs that you don't even like. I could probably recognize a lot of songs I don't like. I don't want to learn them, but I did because I've heard them. So some of these things might be good, some might be bad, but you learn them through exposure. We retrieve things by being exposed to retrieval cues. The more things that are the same, more things that are similar now to what happened when the event was first experienced, the more likely you are to remember. So that's why elaborative encoding works. You've got more memory cues. Retrieval cues tend to vary in terms of their association strength. So more associations, better memory. The more things that are associated with what you want to remember, the more likely it is to be able to be easily stored and retrieved. This goes back to that example I used earlier where everything started to look the same during early COVID online times. I didn't have the association cues. I just sat in my little office at home, which was a spare bedroom, on the same laptop every single day and did everything. It all started to look and sound the same. I was having a conversation with somebody about reading as well. How many of you like to read on a Kobo or an e-reader a lot, novels or nonfiction books? I find it really useful when you're on vacation because you can take 2 or 3 books, right? You can read in bed or you can read on the beach and not worry about anything getting in the way. But I also find that when I read on an e-reader, I don't really remember very well because I don't have the spatial cues. I don't remember that this thing I read was over here in the book because everything is just kind of on the same screen. So for me, I find the e-reader really good if I'm reading fiction. If I'm reading a fantasy book or if I'm reading a police book or a detective novel, it's kind of really easy to just sort of breeze through and enjoy the plot. But if I'm reading a nonfiction book for where I might want to remember a specific fact, I find that my memory for what I read is really poor because I just kind of click the button and go through. And I think about it when I'm reading it, but then I forget what I read a lot more easily because I don't have those contextual cues of being able to flip back to something and remember that it was a few pages earlier, or go back and look at the map or a picture or an illustration or a diagram. So you need to have good association strengths. Repeated exposure to things increases their availability. This is seen most easily with classical conditioning. This is a type of memory that you don't really have to try to learn. So sometimes retrieval happens outside of consciousness. We remember all sorts of things that we're not conscious of. This could affect your behavior. You can treat people differently based on unconscious information. Things that you've learned over time might affect the way in which you interact with people. This is sometimes referred to as an unconscious bias, where you might interact with people differently based on things that you've learned incidentally. But this has its roots in basic physiology. So you probably all know this from intro, right? You all know what classical conditioning is. This is the kind of conditioning where if you play a bell and play a bell while food is there for the animal, they start to salivate when the bell is played, even before the food appears, right? So it has to do with co-occurrences. You can see this with eye blinking. If I were to puff air in your eye, you blink. right? Anytime there's an air puff in your eye, you're going to blink. It's a natural response. If you go to the optometrist to get your eyes checked, have you ever had to have that test where they sort of blast air in your eye? Kind of, you start to blink your eyes before it even happens because you're kind of expecting it. That takes an unconditioned stimulus, unconditioned meaning it's a natural reaction, like the air puff, and an unconditioned response. So you don't need to learn the connection between an air puff and blinking your eyes. It just happens. It's a reflex. You have no control over it. But what you could do, and what psychologists did a lot in the early 20th century when they were trying to understand this relationship, is sometimes you can pair an additional unconditioned stimulus, something that shouldn't have that effect, like a light of a certain color might come on at the same time as the air puff, or a few milliseconds ahead of time. What most organisms will do is learn to associate that as a predictor. If the light always predicts the air puff, you can start to blink your eyes before the air puff even happens. And eventually what you would find is the light causes the eye blink even without the air puff. So you start to learn a new association. That's a really basic form of memory. Most of us see this really obviously when you notice things like notification badges. How many of you have notification badges on your device turned on so that when you see them? Does it cause you any degree of anxiety when you see them and can't clear them? I find that really upsetting. I don't know why. But if there's voicemail, even if I know it's garbage, I don't like seeing it there. There's something about seeing that badge there and not being able to clear it that bothers me. Because most of us, if we use a device, know that this corresponds to something that requires our attention. We don't know who's messaged us or what's happened over here. This is an old graphic because half of these companies don't even exist anymore. We know that something has happened that's going to require our attention. Either somebody has messaged us, or something has happened to some content that we put out there. Somebody liked something or shared it again. So this means that it corresponds to something that really is important to you, even though the number itself or the badge doesn't have any real meaning. We've tended to give it meaning such that it now has its own memory representation. And it might cause you to think, oh, there's something I got to pay attention to. I've now learned an association to a notification badge that I didn't have before. We talked about this on the first class, where most of us have our notification sounds turned off on our device. In fact, most of you probably have a device that doesn't even vibrate. It doesn't do anything. It just sits there silently, but you still check because you've kind of replaced that notification already in your mind. Now you're sort of expecting stuff to happen and you just check on a regular basis. So now it's become part of your memory. That is a type of memory, a non-declarative type of memory. So let's put all this together and let's talk about memory errors for the rest of our class. But what this means is that memory takes a lot of different characteristics. It's fast. Sometimes memory is something that has a really short duration. You can encode things really quickly. Sometimes it takes a long time to encode things, such that you don't really pay attention to them and you miss a lot of details. Sometimes things become part of your memory forever. There are lots of things that have probably happened to you, events that you don't ever forget. But there are facts that you probably won't ever forget. Just like I suggested, I don't forget, I've never forgotten my home phone number that I probably learned in 1974. I still remember the same home phone number. It doesn't work. It's no longer an active number. I don't answer it, and I don't call it, and I don't give it out, but I still remember it. And most of you probably have things like that you learned a long time ago that you will literally never forget. And then there's other things that you probably learned, like earlier today in today's lecture, which you probably won't remember at all. Or you might struggle to remember. So memory has a lot of those characteristics. It's very flexible. It's good, but it lets you down all the time. So let's talk about how memory lets you down. Yeah.
How about selective memory?
Selective memory. So memory, you mean sort of like remembering things that you want to remember, but maybe not remembering things that you don't want to remember. Yeah, I mean, sometimes there are things that we don't want to remember, but we still do. because maybe they're things that are sort of unhappy experiences. If you remember a lot of unhappy experiences, you might be selectively remembering things with a negative bias, which might lead to negative thoughts and negative cognitions, which could ultimately lead to a mood disorder if you tend to remember a lot of bad things. Even if that isn't true for the experiences that you have. If you have a negative cast to the things that you remember, you're interpreting things in a less positive light. So that does happen. So let's spend the rest of today's class talking about all the ways that memory lets you down. One or two of these slides will be familiar to you if you took cognitive psychology with me, but others won't. So first is from the text, is to just point out that even though we're going to talk about memory errors, mostly memory errors come from a place that's well-intentioned. Your memory makes mistakes mostly because your memory works really well. Almost all memory errors come from a system that works really well. Forgetting doesn't sound great. If you forget stuff, it's really hard to explain that as a benefit, but sometimes forgetting is useful because maybe you don't need to pay attention to everything all at once. So you do forget things. So some degree of forgetting is useful. In other cases, see, I can't ignore that there's a notification because I forgot to turn off I don't know who it is, but I'm not talking to you now. It's nobody useful. I mean, is it ever anybody useful? It's almost always could be spam, could be fraud. What was I talking about? Do you see the problem with notifications? Now I don't remember what I was talking about. I was talking about how memory doesn't work very well. Forgetting can be useful, but a lot of memory errors are not just that I forgot something, it's that I got it wrong. I remembered something slightly different. That's usually because your memory is working the way it's supposed to. Memory is designed to create new behaviors. You kind of want your memory to learn. If you want your memory to be learning and to be improving and to learn new things, to make new discoveries, you kind of want your memory to change over time. So ideally, you want your memory to change. It's only when you don't want your memory to change that you notice that it made a mistake. So for most of us, we need our memories to be flexible and to stretch the truth. That's a useful type of memory, is to change over time. But even though we might refer to that as learning, sometimes you are let down by the fact that your memory got it wrong. Well, let's talk about how your memory gets it wrong. I talk about this in the textbook. This is 7 ways in which your memory makes mistakes. And these are kind of connected to each other. We'll talk about them briefly. Transience is the tendency to lose information across time. Most of us just lose access to information. If you don't rehearse it, if you don't think about it, you will eventually start to forget things. Not everything. You'll continue to remember your home phone number, but some facts just eventually fade with time, or they consolidate with other things. Maybe 2 or 3 things that you used to remember as separate kind of condense into one general idea. So they sort of condense over time. So they're transient. Memories you do lose access to, whether through forgetting, interference, or retrieval failure. Another problem with memory is that we tend to be absent-minded. Everyday memory failures in remembering information and intended activities caused by insufficient attention. That's what most of my memory errors feel like, and that's probably what most of your memory errors feel like. You just weren't paying attention. You were kind of absent-minded, and so you missed something. You missed a piece of information. If you are sitting in this class and starting to feel sleepy, your attention is starting to get lax, right? So you're probably going to miss some information, which is why it's probably helpful to have a recording afterwards. If you fell asleep from 11:46 to noon, you might have missed some information. You can go back and see what that information is. But sometimes, so these are kind of memory errors that it's really hard to kind of see how they're beneficial. Sometimes you just miss stuff. But sometimes blocking, this is a kind of memory where you don't remember something even though it's there. That feels a little worse. We might refer to this as tip of the tongue phenomenon. You know it. So you have a meta memory. You have awareness that you have this fact, that you should know this piece of information. You might feel this when you're taking an exam and you're trying to remember something and you think, I know that. I studied it. I know I studied. I actually remember studying it yesterday. I can remember studying this yesterday with my friend. Have you ever been in those kind of situations where you know something? You can even remember learning it. So you have an episodic memory that, yes, I sat down yesterday with my friend and we both studied this piece of information and I knew it then, but I don't remember it now. That's a type of blocking. Other things are remembered, but not the fact that you want. And so sometimes it even feels like you can say the right answer. That's referred to as a tip of the tongue phenomenon, where you can kind of feel yourself saying the right answer. If you're trying to remember the name of someone or the name of or a fact, you can almost say it. You can feel your mouth saying the right answer, but you can't quite get it. That suggests the information is there. The motor information to say the words are there, but you don't actually have all of it yet. Something is blocking it, and usually it's something else getting in the way, some other memory coming up. Misattribution is a big one. We'll talk more about this. This is remembering a fact, but attributing it to the wrong source or the wrong context. This is where you can be lied to or gaslit. Something happens, you remember a thing, but you don't remember all the context. If somebody tells you something that's contrary to what you believe you saw, and then later tells that thing to you again, you've got a conflict now. You've got the original fact, and then you've got the alternative fact that somebody lied to you about, and then 2 days later, you've got the lie again. Now you've got 2 lies and 1 truth. Eventually, that lie starts to seem like a stronger memory, even though it's from the wrong source. That's called suggestibility. So those retrievals, the tendency to incorporate information provided by others into your own recollection. That's why we're all susceptible to gaslighting, right? We're all susceptible to people telling us that we've seen something that we didn't actually see, because we probably saw part of it. And then we remember somebody telling us something. And then we remember somebody telling us something again. And then later when we go to remember it, it all kind of gets squashed together into a single memory. And maybe there's stronger information for the lie than there is for the truth. We also have bias in our memories, tendency for knowledge, beliefs, and feelings to distort recollection of previous experiences. So sometimes we remember things because we're biased to remember things that are positive or negative, to remember things in a different way. And finally, memory can be persistent. There are lots of cases where you wish you could forget something. The tendency to remember facts or events, including traumatic memories that one would rather forget. There are probably lists of things you wish you could not remember. You wish you could unsee, but you know the expression, I can't unsee that. Once you've seen something, and especially if it's troubling, maybe you think about it. And you think about how troubling it was to see, and then it becomes a stronger memory, and you think, I wish I didn't have to remember that. And every time you think, I wish I didn't have to remember that, you remember that. And it becomes a stronger memory. So sometimes memory persists even when you don't want it to. 2 or 3 more examples, and then we'll be done for the day. You probably already know this example, but let's go through it briefly and talk about sort of the modern context. This is Loftus and Palmer's classic misinformation effect, one of the foundational studies in memory errors. You see a short clip of a car accident in this study. So a video that shows a vehicular accident, pretty straightforward. And then you're asked, how fast were the cars going when they hit each other after the fact? And you estimate how fast they were going. Other participants would be asked, how fast were the cars going when they smashed into each other? And you can probably imagine, even if you never saw this description of this experiment, you probably imagine what the results are going to be, right? If you're asked how fast they are going when they hit, you estimate a slower speed than if you were asked how fast were they going when they smashed. Something about talking about the memory right after you've seen it changes your ability to retrieve it. And every time you retrieve it afterwards, it starts to distort the memory. And so in her original study, which has been replicated in lots of other ways, participants who were asked with smashed estimate a higher speed than participants who were asked with words like bumped, hit, or contact. Same video. Everybody sees the same video. They have no idea what the speed is because they're just estimating it. And it's only the question afterwards which distorts the memory. So they retrieve the memory. Everybody, in theory, retrieves the same memory. but retrieves it in a different way depending on how they were probed, how they were asked after they saw it. That becomes part of the memory. What's really interesting about this study is the follow-up. In the follow-up, you might ask a week later, sometime later, for additional details. And what she found is that participants who were asked, in this video, there was no broken glass. So the cars hit each other, or smashed, or contacted, or bumped, and no glass was broken. So there was no smashed window. But something about smashed sounds like there's more broken glass, doesn't it? So even if I didn't see any broken glass, if I was asked a week ago, how fast were the cars going when they smashed into each other, I am more likely to incorrectly remember broken glass. No broken glass, but I think I saw it. So that's an idea of suggestibility. And what Loftus suggested is that eyewitnesses to anything, eyewitnesses to an accident, eyewitnesses to a crime, really can't be trusted. You can get a lot of eyewitnesses, and then maybe you can get a picture of what happened. But a single eyewitness, as soon as the event happens, their memory is going to be tainted by the way in which they were asked about it afterwards, or even the way in which they asked themselves about it afterwards. They could think that they saw something different, and then it becomes part of what they saw. This makes a lot of sense, I think, in light of what we talked about before the break, which is that change blindness effect. If I don't notice a person in front of me changed, it suggests I wasn't paying attention to it. If you don't notice broken glass in an accident that happened right in front of you, you might make it up because you thought it was there. So we know we're not paying attention. Many years ago, I was at a conference, Philadelphia, and I was walking from the hotel to the hotel where I was staying, to the hotel where the conference was going to be at, and I heard a noise behind me. It's in the morning, on a Sunday morning or a Saturday morning, and I turned around, and there was a car accident right behind me about where I walked. So it was like a traffic circle. Here's a road, here's a street, and I walk across the street like this, and I turn around, and right where I had walked, a car had skipped over the curb and flipped over on its upside down right where I was a few seconds earlier. And I thought, well, that was lucky. I would have been hit had it happened. In my mind, I imagined that what I saw afterwards, because I saw the car upside down and I heard the noise, what I imagined was that I turned around and I saw the car like in mid-flight, like a movie. I didn't think I really saw that, but I have no idea anymore, because I kind of thought that's what I saw. And now I cannot remember exactly afterwards. It's like, did I really see a car flip over in real time right where I was? Or did I just think that I saw it flipped over based on what I saw afterwards? I mean, it had flipped. I just don't know if I saw it or not. If someone had asked me afterwards, something about the driver, I could probably answer with certainty that I saw something, but I don't really know. Like I was kind of certain, but kind of not certain. And that's what a lot of these things are like. So what I suggested is that some of these are distortions. They're distorting what you really saw. You really did see an accident, but you distort the intensity of it based on how you were asked. Other kinds of errors are really intrusions. They are facts that weren't there. That broken glass was never there in that video that you saw, but it intrudes on your memory. So our memories are very, very flexible. Eyewitnesses can't be trusted. And that's why I suggested if only there was better video. But the problem is even video isn't very reliable. Set aside the fact that videos can be faked. Most of us can tell the difference between AI videos and real videos. But there are lots of real videos that show different things. How many of you are familiar with all of this from a few weeks ago, right? This is really a tragic event. And when it happens, nobody could agree, even though people saw it in real time. Many people saw it in real time and assumed that this was the unlawful shooting of an innocent American citizen by federal law enforcement officers who didn't make the right decision. Other people saw it and assumed that the law enforcement officer was acting in self-defense and had been hit by the car and behaved accordingly to someone who was going to try to use their car to run people over as if they were a terrorist. And the problem is that Immediately, and how many of you followed this about the time that it happened? You remember this when it happened? Immediately after it happened, different perspectives were announced even before all the video was available. If you probably recall, the Trump administration immediately denounced the driver, the victim, the person who had been shot, as being at fault for potentially trying to run over the agent, and suggested that even the video backed that up. Others suggested that, in fact, the woman was trying to drive away and was trying to made no attempt to hit the agent. Multiple videos show kind of the same thing depending on what your question was. So it's really difficult once you've started to think about something to process even video evidence that's contrary to the memory that you've formed, to the idea that you formed.
Wouldn't past biases affect that as well?
Yeah, definitely past biases would affect that. If you're already thinking about things from the perspective of a law enforcement agent, someone who is been working in a dangerous setting. You might think about this as something where the law enforcement agent acted appropriately, even though tragically, and that's a possibility. You might also think about this from the perspective of a protester who might have the right to be able to protest and not expect to be shot. Your past biases are going to affect the way in which you perceive this. But the issue is that even when the video is there in front of you, people can still draw different conclusions, even when multiple videos can be put together to show one alternative. It's possible to see the other alternative, and that can start really quickly. As soon as you've been given information or asked about what you saw, it changes your memory after the fact. You can produce really simple false memories. All of us are susceptible to false memories. Most of you probably know this example, but if you don't, let's do this really quickly. So what I'm going to do is I'm going to show you a bunch of words, and your job is to remember all of the words. And then there's going to be a QR code, and you can then select which words you saw. So yes, I saw this. No, I didn't. So you don't have the words on your slides. This is the one case where the slides that I'm presenting differ from the ones you have, because if you had the words, it wouldn't be a memory test. You would just have them right there. So if you've fallen asleep, wake yourself up for just a split second, and then we're just about finished with today's lecture. Let's go through this really quickly. I'm going to show you these words, read them to yourself, and try to remember as many as you can. Okay? All right, if you've got you can do the QR code or you can use your device. It's going to be a recognition test, and we'll look at the results. I feel like I picked the wrong set of words for when people are feeling tired. I've got 131 responses. I'll wait just another minute. We don't need to look at all of them, but we'll just look at a couple of critical items. So this is just a really simple recognition task. Did you see this word or not? Rough, most of you would have correctly selected no, because that isn't a word that was displayed. Whereas bed, most of you correctly selected yes, because that is a word that was shown. River, a lot of no. Rest, a lot of yes. Window, a lot of no. Awake, a lot of yes. There's yawn. And we need to, so the critical word here is sleep. And you can see sleep does look a little different. The interesting thing about sleep is that it's not one of the words that I presented. We'll go back and look at the list if you don't believe me, but I didn't have the word sleep on the list. So if you are a person who selected yes, and it's about 50-50, as a few more people correctly rejected it, but we're kind of on the halfway point, and that's a lot different from some of the other words that didn't appear. So the word rough, only one person incorrectly selected yes. Everybody else said no. Correct rejection. If you selected yes for sleep, why did you select yes?
Well, all of the words that were presented, it like semantically, to me, it was like all words revolving around sleep.
They're words that revolve around sleep. That's exactly right. Anybody else have an alternative explanation? I mean, that's the right explanation. So if you selected yes, or how many of you selected no, but thought like, I'm not sure. I think sleep might have been up there. Or you thought, wait a minute, I don't think I saw sleep, but I'm not feeling very good about this. Or I don't think I saw sleep, and this is the trick, and this is probably what we're going to talk about on the results slide. They're all kind of connected, but the idea is that obviously, even if you correctly rejected sleep, you thought about sleep, right? I mean, obviously, after the first 2 or 3 words, you're like, these are all sleep words. These are obviously sleep words because there's yawn, there's bed, slumber, there's tired. These are all words around sleep. And even if you knew that sleep wasn't one of the words, you still thought about sleep. That's the nature of a memory error. In this case, is it an error? I mean, it is an error because you didn't see the word. It's not an error in the sense that you did actually see the word. You just saw it in here. You didn't see it out there. So from your brain's perspective, it almost doesn't care. Your brain doesn't really know the difference. This is kind of a source error. You really did experience the word sleep. It's just that sleep was experienced internally as a result of spreading activation, or as a result of overtly being aware of the fact that all of the words were sleep words. Even if you got this answer right, you experienced the word sleep. You just didn't experience it out there. So the only thing that's different between sleep and the other words that were correctly remembered is that sleep was activated only in your mind, whereas the other words were activated outside and in your mind. So there's that really tiny difference, and it's really hard to notice that. So this is a case where most people show false memory effects. The question is, did you remember seeing this word? And if you said sleep, yes, you made a mistake. You incorrectly recalled a word. Let's go back to my slides here. We're almost finished with today's lecture, just a little past where I expected. This is known as the Dease-Roediger-McDermott false memory task, or the DRM task, because 2 different researchers at 2 different times kind of discovered the findings. Researcher named Dease in the 50s and later Roediger and McDermott in the 90s. Basically, false recognition is often as strong as an accurate memory for target items. So in a list of words like rage or mad, the lower word, anger, I used sleep words instead of anger words. I should have corrected that. Feels like it's as strong. And the issue is it's a spreading activation. So the things that help your memory, like elaboration, also hurt your memory by making it harder to remember individual things that happen. Let's just briefly talk about some of the findings here, and then we'll wrap up for the day. So when Roediger and McDermott talked about this in the 90s, they actually created lots of lists. So you did a very simplified version, a single list with one target. But what the subjects in the task actually did was learn lots of lists of words where there was typically a target, anger, and then lots of words around it. mad, fear, hate, rage, temper, fury. We did sleep, bed, rest, awake, tired, dream, wake, snooze, blanket, doze, slumber, snore, nap, peace, yawn, drowsy, all kind of sleep words. And so there are a whole bunch of lists, and you might learn list after list without ever seeing that target word, the word that's kind of the gist at the middle. Regular class meeting, instructed, just like we were, to hear, not see, list of words tested immediately. They did an exam book, so they're doing recall. And they had to learn a list and then another list. And they did 2 judgments. They made a yes or no, I remember it, and then they also made a rating of probably old. So they kind of rated them, not just yes or no, but really yes and really no. And what they found is that for the critical lure, that's the word, the sleep word in the list that you learned, they made a mistake. So studied words, those are the words you really saw, people gave definitely old. That's a 4. For unrelated words, like, what was the first unrelated word on the list? What was it? Rough. So for rough, everybody says 0. That's not really, it's definitely new. That's not old. But for sleep, 58. So 58% are choosing definitely old, kind of almost like the proportion that we saw. I just asked you to make an old new. He was asking his participants to make a definitely old, sort of old, probably new, definitely new. But the same idea. It's not everybody. It's a little bit more than half or around half make that mistake. Okay, so let's just summarize briefly, and then I'll show you the QR code, and you can be on your way for your quiz in just a minute. Your memory isn't perfect. It underlies almost everything you think about. It underlies all of the decisions you make, the problems you solve, the reasonings that you have to do, the way you behave, the way you plan, and it's not perfect. It doesn't remember things when it should. It remembers details that didn't happen. It's suggestible. It's prey to bias. And as soon as something happens, you immediately start adding to it, or you forget bits and pieces, or you remember things that didn't happen. It's just not a very good system for that. It's a really good system for heuristics. It's a really good system for generalizing. Many of the processes which aid memory, like context and semantics, also lead to errors. Same things that help you remember stuff can also help you make more mistakes. You can have errors of things that didn't happen, like intrusions, or errors of things that did happen, but to different intensities, like distortion. Okay, if there's anything that didn't seem clear, feel free to let me know, and I'll try to explain it next week. Remember, quiz number 1 is available in 20 minutes, and it'll be available for the next 12 hours. See y'all next week. And I hope your next class is in a warmer classroom. This is too cold.
In the other paper students we had a meeting, right? So at this point, I need to. No,
So tired.
Right.